Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from limits, right? And here we have the problem to find out the value of this limit, which is the limit x tends to 1 plus, and here we have the fractional part of x and sine x minus 1 divided by x minus 1 square, right? So here we see that we have to find the right hand limit of this function because x approaches to 1 from the right of x is equal to 1, right? So here we have x is equal to 1 and we are approaching towards x is equal to 1 from the right of x is equal to 1. So this positive sign indicates that we have to find the right hand limit of this function involving the fractional part function, right? So here we have the fractional part of x, and we know that the domain of this fractional part function is the set of all real numbers, and the range is from 0 to 1, right? So here we'll use the definition of fractional part function in terms of greatest integer function, right? We know that the fractional part of x is defined as x minus the greatest integer of x, right? So we'll use this definition and to simplify this limit, right? So let us start. So let us call this limit as L, right? So here x approaches to 1. So we'll take x is equal to 1 plus h, right? Where we have introduced this quantity h as an infinitesimally very small quantity, right? And h is a positive quantity, and h, it lies between 0 and 1, right? So when x tends to 1, then obviously h tends to 0, right? So now we'll transform this limit in terms of h, right? So before doing this, let us substitute here the fractional part of x as x minus greatest integer of x. So we can now write limit x tends to 1 plus, and here we can write x minus greatest integer of x, and here we have sine x minus 1 divided by x minus 1 square, right? So now we can replace x by 1 plus h, and we'll take the limit h tends to 0, right? So here we have limit h tends to 0, and here we have 1 plus h for x, and here we have greatest integer of 1 plus h, and here we have sine x minus 1. So x minus 1 can be written as equal to h, right? Taking this one to the left hand side, we get x minus 1 is equal to h. So here we have sine h, and here we have h square, right? Okay, so now see, here we have an important term, that is greatest integer of 1 plus h, right? And we have just said that h is a positive quantity, and it is a very small quantity, and it lies between 0 and 1, right? So 1 plus h, it is slightly greater than 1, but it is less than 2, right? So 1 plus h is greater than 1, but it is less than 1. So by definition of greatest integer function, the greatest integer of 1 plus h should be equal to 1, right? So here we cannot directly substitute h is equal to 0, right? So greatest integer of 1 plus h is equal to 1. So now we can write limit h tends to 0, and here we have 1 plus h minus 1, and here we can write sine h over h square, right? So here 1 and this one get cancelled, so we are left with limit h tends to 0, and here we have h times sine h over h square, and this h and this h get cancelled, so we are left with limit h tends to 0, and we have the well-known limit that is limit theta tends to 0, sine theta over theta is equal to 1, right? So here we have limit h tends to 0, sine h over h, and that is simply equal to 1, right? So the value of this limit is equal to 1, right? And similarly, we can also find the left hand limit of this function when x approaches to 1, right? And this problem is left as an exercise for you.